All right, thank you. So this is Containerless Django, deploying without Docker. I tried to use some buzzwords here, but really this is just like regular deployment. But we're going to try to do a little better. So real quick about me, I'm the founder at Lincoln Loop. We're a Django development agency. We do kind of full stack Django solutions, so everything from design to DevOps, and that's primarily my role at the company these days. I've been doing it for a long time. Before that, I was sysadmin, and I'm the co-author of a book, High Performance Django, which is also has quite a bit about deploying Django. So I've done quite a bit of this. How many of you have seen Stranger Things? Or maybe not seen Stranger Things? Okay, well, I'm going to make some references to Stranger Things in this talk. Halloween's coming up. I don't think I'll make any major spoilers, but I'll reference a few characters in it. So Docker is cool. I like Docker. Docker's kind of like this Steve Harrington guy, right? He's got like, great hair. He's like the cool guy at school, drives a nice car. I feel like, the kind of popular opinion of Docker these days is the same. Like, it's great. It solves all your problems. And like I said, Docker is cool. One of the things I really like about it is this pipeline that it gives you. It kind of forces you into, you write code on your machine, you check it in, and your continuous integration system picks it up. It builds your image, which you can then test and push that image out to any number of servers in any different environment, and you can be guaranteed that the thing you tested is the thing that you're running in that environment. It gives you some security right out of the box. So in the unfortunate event that a hacker attacks your system and gains access to your application in ways you don't want them to, it's very difficult for them to kind of leak outside of the container and do things to other services or systems. It also gives you isolation, and beyond that security isolation, it gives you isolation from kind of having some sort of global state that you have to deal with. So when you're deploying lots of different services on a single instance, you don't have to worry about conflicting versions of software, libraries, all that stuff. And it gives you this developer parity from development machine through to production. So I know that the thing I run in development is the same thing that I run in development or in production. That's great. I like all these things about Docker. So Steve's over here like, hey man, just bundle the entire OS. Like all your problems are going to go away, right? Well, not exactly. This is a great solution if your platform as a service, if you're running hundreds or thousands of services. Absolutely, like this is probably the right solution for you. But my guess is most of the people here are not in that scenario. You're deploying maybe one or a handful of services. And maybe going to the point of bundling the entire operating system is overboard for you. So that kind of leads into some of my philosophy when I'm building systems. And I'll use a couple of quotes here to show I'm not like the only person that thinks this way. Mike Perham, he's a Ruby developer. He wrote Sidekick, which is sort of Ruby's version of Celery. He says, no code runs faster than no code. No code has fewer bugs than no code. No code uses less memory than no code, and no code is easier to understand than no code. So the less code you run, generally the better off you are. And this one is Henrik Jorteg. He's a JavaScript developer. And he says, for an optimal programming experience, constantly ask yourself, do I really need all this crap? And I think it's important these days. Like we are bombarded with frameworks and new technologies and all this stuff. And it's good to, rather than just sort of adopt it willy-nilly, take a step back and say, like, is this what I really need? So Docker has its drawbacks as well. It's slow. Like you're, downloading entire operating systems and uploading them and all this stuff. You've got really big build artifacts, and it takes time to ship those around, build them and all that. When people say Docker's lightweight, it's not a lightweight solution. Like it's lightweight compared to running an entire server or compared to like a virtual machine like we used to run them, but maybe not as lightweight as running something directly on a Linux system like we've done for years. It creates all these extra abstractions. So when you're running in Docker, you've got now an extra network you have to handle, and doing things like working with the file system can become more challenging. So you don't get it for free. And kind of the same philosophy I talked about before, more software, more problems. Docker is about 1 million lines of Go code. There's 3,000 open issues for it. Like, you should not expect that it just runs flawlessly for you all the time. And it's an extra layer on top of what everybody has been running for years. So the cool guy, Steve, like, maybe he's not so cool. Maybe he goes in the parking lot and drops your friend's camera on the floor. How did we get here? Like, like one of the things, like, we should kind of take a step back, like, if we're gonna look at things, like, why is Docker so popular? And I would say one of the primary reasons is deployments kind of sucked. Like, we didn't do them very well. We had this issue for a long time where, we use pip and requirements files, and we'd install stuff, and then some sub-dependency of our dependencies would change versions and everything would break. A lot of times we're building software on a server that we also want to run it from. So we had all these build tools and development packages that had to be installed. There was like tons of opportunity for things to kind of go wrong, or to kind of deal with this global state and lack of isolation and conflicting versions of software. And today, if you're building Django apps, there's a good chance you're probably touching Node too. You might be using something like Webpack to build your JavaScript files. So now we've just like compounded the problem. Like, not only do we have to deal with all the Python versions and all that, but we also have to deal with the Node versions. If you're doing ops work and you were trying to build stuff like this, these things probably made you mad and frustrated at your developers that were throwing all these new tools at you. So if we were kind of, had these sucky deployments, what is the ideal deployment? In my opinion, it's this. You download a binary, you create a configuration file that says how you want that binary to run in a given environment, and you run it. And this type of software exists. Like Traffic and Telegraph, those are services built with Go. Nginx, which I'm sure many are familiar with, web server reverse proxy written in C. You can download a binary of these, you can give them a configuration file, and they run. And I think if all software worked like this, or more software worked like this, that Docker would be, would have a lot less popularity. Like, I don't see a lot of benefit that it brings if we had software like this. But Python is not C or Go. C and Go have really good stories for doing stuff like this. Python requires a virtual machine, the Python virtual machine, to run it. You can't just run Python files without it. It uses dynamic linking, so your Python files may reference some library, and it's expecting to find those libraries kind of in your global system. And packaging isn't straightforward. There's no obvious solution to, I want a single file that is my Django project or my Python project, and I want to run it. So in our Stranger Things analogy, I would say Python's kind of like Jonathan Byers here. He's, this emo guy, he's got a bowl cut, he's, confused about where he fits in, like, not nearly as sleek as Steve is. And the question I've been kind of asking myself is, can we do better than this? Like, is there some sort of holy grail that solves this solution for Python? I've wanted this for years. I think ever since I saw somebody run, Jenkins in a single download, and you can like run Jenkins, like, how can we do that with Python? Well, this would be a terrible talk if we couldn't do better. We can do better. And we already are. Like, there's a lot of things that we're using every day that have improved the situation. So pipenv and poetry, a lot of you probably maybe worked with pipenv or at least heard of it. It's creating a lock file that is making sure all our dependencies, we remove that problem of dependencies shifting underneath us with these tools. We can guarantee a kind of deterministic build. when I install a project on one machine, I'm going to get the same packages on another machine. Precompiled wheels exist for lots of popular libraries. So, one of the problems was all these build and development tools that we needed just to install our project. Pillow, the image manipulation library, and PsychoPG2 binary are two really common ones. That's the one you use to connect to Postgres. So I can install these packages. They have compiled C extensions in them, but I don't have to worry about it. I don't have to build them. I don't need the build tool chain on my machine to use them. But there's still a lot of holes. We still have this whole like assembling a virtual env thing that we have to do. We have to deal with the static files from our Django application somehow. And we need to have a production web server. Like if we want to just download a single thing and run it, it has to be a web server. There's lots of projects out there that have kind of worked on this problem. Lots of people have the problem and want to solve it. So I'm not going to go through each one of these individually, but these are all projects out there that are designed in some way to kind of create a pipeline with Python where you can build your software on one machine and then deploy it elsewhere without needing to kind of build and assemble it. PEX is an interesting one. It's been around for a long time. It's from Twitter, and it uses this concept from Python called zip applications. And I always shied away from PEX. I'd heard like it's slow, it's cumbersome, it's hard to use, whatever. So it's not something I ever kind of saw as a viable solution. But zip apps are interesting. So zip applications, they've been part of Python since version 2.6. They're not dead. They just got improved support in Python 3.5. And what they are is a way to create a zip archive of Python files, and then you can actually run the zip archive with Python. It's kind of weird and crazy, but it works. So the big problem with zip applications is there's no way of handling dependencies. So if I want to run, I can run my Python files without a problem, but if I want to run Django, there's no kind of way for me to pip install it. Well, there's a new project out there called Shiv, and it is kind of a reimagination of PEX. And it comes from LinkedIn, and it's a way to build these zip apps and include all the dependencies in them. So you can then generate a single artifact which you can run through the pipeline, build, test, deploy. The common extension for zip apps is PYZ, so I can create a zip app and then execute it kind of like a binary. I still need Python, but other than that, everything's included. So can we teach Django to run as a zip app? The answer is yes. The first thing you need to do is make sure your Django project is a proper Python package. I would recommend doing this anyways. In my opinion, it's kind of best practice. So it's very simple to do. You just create a setup.py file, you drop it in the root of your repo, and really there's only three things necessary here. Name, version, which you can set arbitrary, it doesn't matter, and packages. Setup tools includes this nice function called find packages, and that will go out and find all your Python files and include them when it wants to distribute your application. The last one here is optional, but I bring it up because we're going to talk about it later. Your console scripts, entry points console scripts. This is how, when you install Django, the Django admin shell command works. And it's basically a way of telling setup tools that when somebody installs this, create a script they can run that executes this Python function. So with this, I could, instead of creating a manage.py file, I can basically do it with this line here in setup tools, and it will create it for me when the project installs. So the next thing we need to deal with is templates and static files. That find packages command will get all of your Python files, but it will gladly ignore all other types of files. So we need to get our static files and templates. The kind of simplest way to do this is to create this manifest.in file. It also goes in the root of your project. And graft means take this directory and anything in it, any subdirectories, all that. So we would include our collected static files and our templates in that. Now we need a production web server. You know, if you're running a Django application in a Docker container, you'd expect when you start your Docker container that it serves web requests, right? So the common ones are GUnicorn and Uwizgy, typically we use. ModWizgy is also out there. I'm going to say that, Graham's sitting in the front row. But we want these to run from our entry point. Typically, what we're doing when we deploy these is we start our web server, and then we tell it to import our application. And we want to kind of flip that on its head. We want to start our application and tell it to run the web server. So you can do that. You could also, Shiv provides a way that you can kind of dynamically swap the entry point when you start it up, but feels like kind of a hack. Let's kind of pretend like it is this, you know, static binary. So one option is GUnicorn and white noise. So white noise you use to serve your static files in an efficient way, and it's not too difficult to write your own management command, which then starts GUnicorn. There's another option which we've released recently called Django Piusky. So we've been working with the developer of Uwizgy. When you pip install Uwizgy, you get a binary executable. It's not a Python thing that you can work with. So Piusky is a way you can build Uwizgy as a library and then import it in your Python code and run it. So this includes that management command I was talking about. So you can run manage.py, Piusky, and you get a kind of production web server right out of the box. Piusky is also distributed on PyPI as a wheel, so you don't have to worry about compiling it or anything like that. It just, you download it and it works. And so with all those pieces in place, now we can build our zip app. What I'm going to do is going to look just like you would probably build any sort of Django site for the most part. If you were using it in Docker or, you know, building it on your server or whatever. I'm going to use pipenv to install all my dependencies. That way I get the benefit of that lock file and that deterministic build. Then I'm going to do whatever I need to do to build my static files. This is the part where you call webpack or grun or parcel or whatever you're doing and make all that happen. Then I'm going to run collect static, get all those static files and collect them into a directory. And then I do the part with Shiv. So Shiv, you can just pip install it, pip install Shiv, it's just Python. And I'll explain these options here. So -o is output. So I tell it I want to create this file called yourproject.pyz. -e is that entry point I talked about. So it says when I run my project or yourproject.pyz, this is the function I want you to call, and this one's the one that manage.py uses. Site packages lets me include a pre-existing site packages directory. So I can point to the one that pipenv used when it installed my project. I can also use this. Shiv accepts most of the arguments that pip does. So you can also pip install projects and they will, or pip install apps and they'll end up in your final zip app. Next is Python. So I can say, like, if this gets executed just by itself, pick up this Python. It ends up as a shebang line, like the first line you often see in a script. You can also call it with Python as the first argument if I want to choose a specific Python. And then the last line there is, those are just standard pip arguments. No deps says install my project, but don't install it with any dependencies that I might have specified. And then the dot is like the current working directory, so that would be where my setup.py file is. So that runs, it builds this zip app, and I'm left with something like this. So I can run my project.pyz, your project.pyz, Piusky, and then I can pass it whatever arguments Uwizky accepts. The only requirement here is that I have Python installed. Everything else is in this zip app. So the next part we need to figure out is configuration. A lot of times you'll see people installing Django apps and then like mucking around with settings files or creating them dynamically and kind of injecting them into the project. That won't work with this solution. You kind of have a frozen state of your Python app. So we want to run the same zip app, but we want to run it in different environments. We want to run it for our tests, we want to run it in staging, we want to run it in production. So one option is multiple settings files. You have a bunch of settings files for all your different environments, and you toggle them with the Django settings module environment variable. I don't recommend this approach. You still have to deal with secrets like database passwords and API keys, and you don't want to put those into your project, so this isn't a great option. Another option is environment variables. So this is kind of the 12-factor method of building apps. You create your application and then you use environment variables to configure them. That's a viable solution. There's another one. This is another project I've been working on with Chris Bevan as well. And it's called Goodconf. So what Goodconf does is it lets you define a set of variables that you might want to change. And this isn't Django specific, it would work with any Python application. And so you create your kind of configuration, and it might be your database URL or your API keys and that kind of thing. And then you can define that in a JSON or YAML file, some sort of structured format that's easy for a build tool or a configuration management system to pump out. And then your Django app will pick up those files and read them. One of the things I really like about this is it lets you document all those variables that you're using to configure your app, which with environment variables, they kind of tend to get added willy-nilly and people don't ever know which ones are available. And the other thing is this will fall back on environment variables too. So I can take my same project and run it the way I want to with configuration file, but I could also run it on Heroku or in Docker where environment variables are kind of preferred. And I don't know if I mentioned this, I think I skipped it, but the other concern with environment variables is it's really easy to leak them on accident. You can have a program crash and it dumps out your environment somewhere, or a child process runs and it now has access to your environment. So by putting them in a file instead, I would argue you get a little better security. So now kind of going back to this pipeline, the Docker pipeline, how do we replicate that with a zip app? So you'd use a continuous integration system. There's a bazillion out there, Travis, CircleCI, Bitbucket, GitLab, whatever. You build your project. That's that slide I showed you with pipenv and collect static and all that, just like you would with Docker. And you're going to run shiv, which is going to generate your zip app. You'll run your tests against that. So you'll have your tests built in as part of that. So you can ensure, again, the thing you test is the exact same thing you deploy. And then once your test pass, you push it to some central location. That could be Amazon S3 or wherever you can pull it down to deploy. And now deployment just is download the thing and run it, which is awesome. Like your ops teams are going to love you for simplifying their life. And it's great for development teams too, because they can kind of take full control over everything in the CI pipeline. If you want to switch, you were using Grunt before and now you want to use Webpack, like you don't have to, your developers can kind of manage that, and they know the only thing they have to churn out in the end is this zip app to be deployed. So zip apps aren't looking so bad. Like Python's looking a little better. He's no longer the kind of awkward dude with the bowl cut, right? But that's not all Docker brings. What about security? so how do we get a similar sense of security here? Well, systemd's got your back on this one. Systemd is awesome. Like, if you are not familiar with it, definitely check it out. It gets a bad rap in the Linux community sometimes, but it is on every modern Linux distro. Learn it, use it, love it. Well, I'll mention quick, if you're not super familiar with systemd, it's how all the services on your Linux machines start up and run and stop and restart and all that. It manages that. And the way you define a service is via a service file, and you tell it what command you want it to run, and you can give it all sorts of other flags that tell it how you want it to run. So I'm going to give you some that are going to deal with security. You drop these in your service file. Protect system strict, that will make your entire file system read-only. So, right off the bat, that's super easy. Like, now, if and the scenario we're protecting against here is some nefarious user has hacked your application and is now trying to run commands, on your host system. So we've now made the entire file system read-only. They can't create any files or edit any files. There's protect home equals true. That just basically removes any removes any access to any home directories. So even if somebody has like the bad permissions on their home directory, like they can't access it. Dynamic user equals true. So best practice is that you run each service as its own user. That way, one service doesn't potentially gain access to things another service is doing. Usually you would create these users as you set up the services. Dynamic user equals true. Just tell systemd, like, hey, do that for me. Like, just create some user, I don't care who it is, and when the service is done, you can remove it. There's capability bounding set. So this is probably familiar if some of you have used Docker quite a bit. This lets you determine the capabilities, the kind of Linux capabilities that the process has access to. The tilde means like negate it. So this says my service cannot do anything in the cap sysadmin group. So that basically is removing like kind of root-like abilities for anything the service is doing. And there's a whole bunch of others too. So I could create an AppArmor profile that gives you really, really fine-grained permission control. And there's these which the systemd docs recommend adding. I'm not going to go through each one. Private temp is an interesting one. That's like a attack vector you see sometimes where two services are both writing to a temp directory. One service gets hacked, and it starts reading what the other service is doing in the temp directory and gains some sort of interesting thing it shouldn't through that. So this will bind mount a private temp directory for every service. Another thing interesting, I don't have time to talk about it, but one of the kind of things that people really like about things like Kubernetes is the ability to do rolling deployments, blue-green deployments, where you have one version of your software running and you want to run a new version. This has typically been kind of a pain point for the Python community, in that kind of reloading and getting the new service running as your project gets bigger, it takes longer for you to start up your service, and it's sort of difficult to do that dance where you take one service down and bring the new one up without any downtime. And sort of the common practice these days is managing that via your load balancer or something, where you bring both ends up. You've got your blue version, your green version, they're both running side by side for a moment. Once your new version kind of passes health checks and is happy, you drop your old one out, and then you just point all your traffic to your new one. If you're interested in it, you can do this with systemd on a single machine without having to orchestrate and coordinate with load balancers or use something like Kubernetes. I don't have time to go into it, but I'd be happy to kind of show somebody after the talk. Isolation, that was the other thing we mentioned was cool about Docker. So how do we handle that? I'll be frank, it's not as good. You still need to install Python globally. If you're using Python packages that are referencing libraries on the server, there's a chance you may need to install those. You don't need the development packages, but you may need the library itself if you don't have these wheels built for all your packages. But that being said, it's really easy to install multiple Python versions on a server. If you're using Ubuntu, there's a personal package archive called Dead Snakes. You can easily install 3.6, 3.7, 2.7, whatever. They'll all happily live side by side. So yeah, Docker's got better isolation, but at the end of the day, do you really need it? Especially if we're kind of bundling our apps in this way. And then how about parity? That was kind of the last thing on my original slide is you get this parity from your development machine all the way to production. In this scenario, you're still going to get it from your continuous integration system all the way to production. That's probably the important bit. As far as locally, you can use Docker. It's a great use case for Docker to run an image that's the same as your deployed machine. Or not. Like, we have lots of developers that work on Macs and deploy to Linux, and that's generally, something you can do these days without being terrified that, the world's going to break. So, pros and cons to this approach. Like, hopefully I've showed you at this point, like, you can deploy a single file Python project. Pros to this. It's simpler. You don't have to put Docker on your server. You don't have to manage a Docker registry or pay somebody to manage one for you. And you are now depending on about 1 million less lines of Go code. My guess is, for most people, when something breaks with Docker, it's like a oh crap moment. Like, I have no way to debug this or deal with this on my own. Hopefully somebody else has dealt with this and I can Google it. You get smaller artifacts, so we're not bundling the entire OS. If you are building Docker images kind of naively, it's not uncommon to have a gig or 2 gig Docker images. With this, you're probably looking more at like 100 megs or something like that. Depends on your project. Because your artifacts are smaller, your deployments are faster. It's a big difference deploying a 100 meg artifact versus a 2 gig artifact. And then finally, it's just Python. Like, there's not a whole lot of magic going on here. There's not 1 million lines of Go code that you're depending on. So when things do break, you can look under the hood and figure it out. Shiv is a very simple project. And I just realized I didn't really explain how Shiv works, so I'll give you that really quick. So what Shiv does is it takes all your dependencies or your site packages directory, it puts it into the zip app, or the zip file, along with like a small bootstrap script. And when you execute the zip app, it will unpack your site packages and then basically inject the path where it unpacked them into your Python path. So it's the first thing that gets picked up. You can read the code and understand it, and it's not terribly difficult to understand. The second time you run it, it knows where that kind of temporary cache it created is, and so it doesn't need to unpack them the second time. Cons. So it's not as isolated as true containers. That's true. It requires Python being installed on your server. It's Python specific, so Docker you can use with any number of languages and it'll work the same. Not so with this. And it's not cross-platform compatible. I mean, technically Docker isn't really either, but you can't build stuff, you can't build a zip app with C extensions on your Mac and ship it to Linux. But you could build it in a Docker container that is Linux on your Mac and send it that way. So what's the sweet spot here? Docker, if you take away anything from this talk, Docker is not for everybody, and this solution certainly isn't for everybody. I would say if you're deploying primarily Python services, you've outgrown platform as a service. I'm a huge fan of platform as a service. Things like Heroku, Python Anywhere, all these options out there. It should be where you're starting when you're looking to deploy stuff, unless for some reason you are like super interested in learning these things. These kind of tools, you don't have to worry about it, they deal with it for you. But people tend to outgrow them. Like they either find like at some point it makes more sense from a financial perspective to bring these things in-house, or they need more flexibility than they get with one of these options. And this is an arbitrary number, but I'm going to say if you have fewer than 50 services to maintain. So if you have 100 services, 1,000 services, something like Kubernetes is probably where you want to be. It's kind of it's designed for doing exactly that. But most people aren't Google scale. Most people are not deploying hundreds and thousands of services. Most people are deploying 1, 2, 10, and at that scale, the payoff might not be there. So, next time you're faced with a scary deployment scenario, I hope you remember there are multiple options. Docker is a great option, but Python is not so bad on its own, and you can certainly have these secure single file deployments with Python. So thank you.
Hi, Pete. Thanks very much for the talk. Have you used Shiv and the zip apps at all with Lambda? I realize it's not entirely, or AWS Lambda or Azure Functions or whatever.
I haven't yet, but yeah, that would be interesting.
I noticed that in the configuration setup.py, you exposed manage.py. I was wondering, for use with mod WSGI, if there might be any way to expose, do you have to expose WSGI.py in some way in the zip? Is that a possibility?
Right, so the way I've been running the WSGI applications with this is by wrapping it in a management command. So I can still call the management command, and then that executes the WSGI application. Another option would be to change the entry point via, so you would install, I'm not super up to date on how mod WSGI works, but I bet Graham has lots of ideas on this. Yeah, so you could execute, you could include other servers in your zip app, assuming they're Python, and adjust the entry point to run those if you wanted to. Thank you.
Yeah.